Hello devs, I'm Cray. In this video series I'm going to show you how I recreated my jam entry to Brackeys Game Jam this year. The theme was Love is Blind and I created a memory game, so let's create our new project and call it One True Pairing. This game mainly will contain only texts and images, so we save our scene and then create a canvas. Because in that canvas we can put everything we need. And let's set the canvas as well. I prefer the scale with screen size and we target a Full HD screen. And after that we add the panel so we can set a background color to our scene. This will be one of the main colors of our game. Let's set it something like light brown, brownish pinkish. The base color of the game is some kind of pink. You will see it in the cards in a later video. And add the horizontal layout group to this because we want two sections. The left one will be for the grid and the right one will be for some text information about the game. And after this horizontal layout group we add two empty game objects. The left will be our grid and the right will be the text panel. And for the text panel we add the layout element. With this layout element we can control the size in a better way because we want this right panel to be thinner especially, and our main game content will be on the left side. And with this vertical layout group we can control the padding and spacing between the elements in this section. We add the layout element as well to the grid panel, so we can set the width as well. I calculated this min width and preferred width by the difficulty settings of the game. Once we have 3 rows and 4 columns, and the other difficulties we have 5 or 6 columns, so that's why we need space for those cards. That's why the left panel is way wider. We add some text to the text panel. And we need Text Mesh Pro for this. One will be a timer. The other one will be a moves counter, where we count how many times you clicked. It's a memory game, so it's kinda, the point will be based on the time and the click amount you do during the game. And we add the pause button. It's a good option to have a pause in a game, I guess. And with that we could give a way to exit the game. Set it to pause and make it a little bigger, at least seeable. Yeah, way better now. And to separate this right part of the screen, we add a background color, so we need to add an image to this text panel. And set it some basic image. And some color. For now this yellow will be good, but later we will change it. Finally we start to do the grid panel part. We create our own C# script in here. To see what we want to achieve is that we have cards. Those cards will be images, and we want them to be positioned in the center of this panel and have some spacing between them, and also have some padding from the edges of the screen. So we create our card grid layout. Its parent will be the layout group of the Unity UI class. And in the documentation we can check what attributes and what functions does this layout group has. And we also need to use the Unity Engine UI namespace, because that is the namespace which includes the layout group. And now there it is. And we delete the mono behavior stuff and implement the abstract classes functions. The last two we won't use, so just to return. And we need rows and columns, because that will be the main part of our game. How many rows and columns does this game has? And in the calculate layout input vertical we can get the parent width. It will be the grid panel's width, and because we use the layout group we can reach this in the rect transform, and as well the parent height can be reached through this rect transform. Rect and height parameter. We should calculate the card size. With this variable we can resize our cards to be well fit to the screen. We calculate the height of the cards based on the parent height and the number of cards we have. And the width will be the height as well, because we want these two values to be the same. And we set the card size with these cell width and cell height variables. Probably this is unlucky to use cell and card at the same time, so let's rename them. It's way better with this. And after we get calculated the card size, we should set all of our cards to be in this size. Luckily we have the rect children in layout groups. We know exactly how many children do we have. And we calculate the row count and column count. That means in which position are we in through the iteration. And from these rect children we can get the children at the I position. With the row count and column count, we can calculate the position based on the card size. So we know where should we put our card in the I position. And we need some functions to set these values, and luckily layout group set child along axis, and in the documentation we can check that there are many forms of this function, and we need the last one, which has 4 parameters. Let's copy it, it will be easier. So we need a rect transform. It's the item what we get from the rect children. We need an axis. It can be 0 or 1 based on that this is the x or the y axis, and we need x position and the card size. And also we need to do this set child along axis in the y-axis as well, with the y position and with the card size dot y. And to check it, we see that we have an error. It says we divide by 0. It's unlucky. It happens when we not set in the editor, so we should check it, and if any of those 2 variables are 0, we should set it to some non-zero value. We set it to the normal difficulty 4x5 size. We can see that if we add 20 cards, because 4x5 is 20, and set some background images, we can see that it's nicely ranged in the grid panel, but we have some spacing only in the left side, and we want to position all our cards in the center of this grid panel. So we have to calculate something, because if we set it in the editor, nothing happens. Because if we set it in the editor, we should use it in the code, but that means that these padding values are available through the code. So we should calculate some padding left values. And we do that by restrict the card size multiplied by the columns from the parent width, and of course divided by 2, because we want the same distance in the left and the right side of the card. And of course we should add it to our X position. And now it's in the center. We want some spacing as well between our cards, so we add the spacing vector 2, and we should destruct this when we calculate the card height as well, and we should destruct this one less time than the rows count. And we can see that our cards will be smaller, but the position is not good, so we should add it to the X pose and Y pose variables. And we add it one less time as well, in the row count and the column count. But we can see that it's not okay. We should distract this spacing from the calculation where we calculate the padding left. Now we should use the row count and column count, and now it's okay, it's in the center. We have some spacing, but we want some padding from the top, because it reaches the edge of the screen. So we add this preferred top padding integer, and we add this preferred top padding 2 times when we calculate the card height. And we calculate this top padding. We should calculate it again because we don't want any pixel to be left out. And of course, with the parent height, we should distract all of our stuff, so the card sizes, the spacings, and we should divide it by 2 to get the top and the bottom padding. And of course the bottom padding will be the same as the top. And now we can see that the cards will be smaller, but of course we should add this padding top to the cards, and now it's nice and clean. Now we delete 8 cards, so we can check the 3x4 easy difficulty, and nicely arranged cards show up in the screen. But when we play with the resolution of our screen, we can see that some of our cards sticking out of the screen. So we should check that the card width multiplied by the column, if it's bigger than parent width, we should calculate the width of the cards instead of the height. And of course we should use the spacing as well in here. It will be the same calculation as above, but at first we calculate the card width, and that will be the card height as well. So it's kind of other route to calculate the card size. And of course we divide it by the columns and not by the rows. And of course we divide it by the columns and not by the rows. And now if we play with the aspect of the screen, we can see that everything is fine and nice. Thank you for being with me. In the next video we will talk about the scriptable objects we need in our game. See you next time. Bye.